Yeah, so it's not a version. Yes. Okay. That's all right. I was like, okay. Yeah, I thought. Yeah, I think he's going to the last one. I was first. Yeah. Yeah. Oh, yeah, yeah. Petty went to, I think the first one was. Pretty good. Well, and that's the thing. Is there? Right, exactly.
If it's over 250 or something.
Exactly, right, yeah, so if it's above, if it's over this thing, there may be some misplaced decimal points. Is this back to that one?
Yeah.
Cool, yeah, so this is what it looked like, and where was the one, oh, right here it is. This is your Hartford, relation.
Yeah, like model. Just exit out.
Yeah, I think by the fourth session. Who's played with you?
We're at 360 live stream from your session.
Really? Never.
I guess what do you mean by play?
Oh, turned on.
Touch
Touch
it.
Does that count? Like, what's it?
Oh, feels like before.
Yeah. So, oh yeah, very good. Yeah, it'll be good time, everybody. So, a bunch of years ago, there were some Italian fellow who was teaching a course in electronics in Italy, and he thought it would be good for people to learn how to play with very basic electronics. So this is far simpler than a laptop. This is the brain that does your laptop. Is how many megahertz or gigahertz? 2 gigahertz or something like that, 3 gigahertz. This is like 60 Anyway, very, very slow. Very, very slow. Very little memory, like 32 kilobytes of memory. Super simple, but the nice thing about that is that it is extremely simple. When you program this, you don't suddenly get like a Windows update or anything like that. It only does what you ask it to do. It's got one process.
So I'm going around. I'm just gonna play my computer.
Okay, are you gonna set up Arduino?
Yeah, I have to download again real quick, so.
Okay, oh, perfect, okay. And then, in fact, I have a fellow in the top left, he's one of the folks that started this thing, Massimo. The course lost funding, and they decided to open source the designs, and so they put the schematics online. And so when you go to the Arduino website, you can see the board and the schematics and the board files, they call them, such that if you just package that up and send it to a manufacturer, you can ask them to build one of these for you. Or you can copy and paste from other designs that people have made and make your own variant of this thing. So that led to this huge movement a couple of years ago that's gotten bigger and bigger around open source hardware, they're calling it. So you can, and I've just learned in the last couple of years to open this file up, see what the different parts do. This is the brain. There's a part that connects to power, and more or less the way this is arranged, you have these pins along the side that connect to the pins on this chip, which is the brain, and you program this and you say, on pin number 12, measure the voltage, and if the voltage goes above a certain level, then on pin A3, turn the voltage high. It's all about measuring voltages on this. And so the world of sensors is also about voltages. So the temperature signal, the light signal, everything gets converted to a voltage, which this can either measure or control. So you can measure and control with this brain, so it's like a little robot. I mean, that's all you need for a little robot. And that's all you need for building sensors, or anything. I mean, so if you search Arduino on YouTube, Arduino anything, somebody's tried to make something with that Arduino. So these chips come in different form factors. This is another version of exactly the same. This is an old school chip that is what they call a through-hole component. It allows you to plug it into a breadboard and solder it by hand. But now modern manufacturing techniques prefer what they call surface mount, and these can be done by robots that just place them on, and it's super fast. And a lot of these components are also surface mount. They don't go all the way through the board, but they're using this so that if you blow it up by accident, you can just replace that and put another one in. But so this is the first version of the board. There are lots of variants. This is another version. Same brain, but different package. And then the riffle that we designed, if you can tell, this brain here is the same brain there. And I really actually works like one of those boards. So what's being shown there is the programming environment for the Arduino, and that's also free software, open source that you download.
I literally just downloaded it.
Yeah, actually, it's that easy to. It's nice when you don't have these things quite set up. You can usually start from scratch really quickly. So you would get one of the, like an Arduino Uno or a board like this, and then you would download the software, and then you connect it via USB to your laptop. And the typical thing that they'll start you out with is you'll have a breadboard like this, and you'll plug an LED into the breadboard and connect some wires, and connect those wires to the pins on the Arduino Uno.
I'm just gonna show you.
Exactly this.
This is a sketch that you can do. They're called sketches. So this is the breadboard, and this is the for control. This is basically a circuit, like a loop. So it's gonna go negative or positive, all that good stuff. So basically, you just connect them. The wires just fit in really nicely. Is it 5V to positive, right?
Sorry.
5V to positive, negative to ground.
Yes.
Actually learned that from Phineas and Ferb. Fun fact. Okay. Sorry. So basically, it's just a giant loop. So like this gives it the power. Positive energy runs, the strips run up and down, so each breadboard is its own side. So the strips run up and down. It powers the buzzer to make the noise, and it goes negative back. It's actually it's simple, but it's fun. I'm not gonna make sure.
Cool. And there are a bazillion tutorials out there for getting one of these and learning how to blink an LED and start with the basics of the code. And so right now, we're in the process of trying to make some basic tutorials for getting started with one of these. So the basic tutorial would probably be you get one of these and you connect. So this happens to be a temperature sensor, and these are nice because they're cheap on eBay, and they can all be on the same parallel bus. So you give it power and ground, and that you can run just these parallel lines for power and ground, and then all of these signal lines can connect. So with one data logger, if you make a circuit board for it, you can connect 100 different temperature sensors. So if you wanted to know the variation in temperature in the soil or in a compost pile or something like that, you could do that. And that's already something that's kind of cool, because the typical thing that you would do with these commercial sensors is buy a separate temperature sensor for each point that you want to make a separate data logger. So that's a neat thing. And so just like there are all of these tutorials for connecting an LED out there are also for any given sensor, any of the sensors that I'm playing with, except for the ones that I'm making myself. There's a tutorial for how to connect it, and somebody's written code. So just like I'm copying and pasting the hardware designs, I'm going online, finding a blog post where someone said, hey, I found this temperature sensor, it's cheap, here's the code that I wrote for hooking that up, and then I add that to my code base on the Arduino thing there. Exciting, boring, cool.
Yeah.
So the original idea for this really was coming out of a conversation with a hydrologist over dinner. Initially, I thought I was talking to organic farmers, and I thought this would be for farming. And most of the people that I was talking to, they were saying they got out of tech to go into farming, so they were not excited about this. But then there was a hydrologist who was like, hey, well, and you can speak to this, but he was tracking conductivity pulses in a river network to see if he could figure out where the sources of road salt were in that river network. And he had a lot of people who had those conductivity sensors in their backyard. And so he said, if you could make like a cheap version of that, that would be cool. So that was the initial plan, to make conductivity sensors. So the first sensor was a conductivity sensor, and because I didn't know how to make a conductivity sensor, but I thought I'd sort of gotten this down, I just made the design modular so that while I'm figuring this out, this thing will stay the same. Down the line, it would maybe, once this gets really figured out, maybe it'd be even cheaper for folks if it's all part of one thing. But that could be, people here could design that, and then the idea is that this thing needs 2 metal probes to be in the water to sense conductivity. So at this point, it's 2 metal screws through a bottle cap. You also need to compensate for temperature, because conductivity is affected by temperature. So you're also measuring temperature with this probe, and this clearly didn't do so well with the waterproofing. But hopefully we found better methods now. And then this connects to a battery and that that ends up just going into a water bottle, and then you screw the cap shut, and then that was the conductivity data logger. You want to see like basic programming of the Arduino?
Sure.
But it's simple, just so you guys can hear it. This is just what the code looks like, and this was like a starter kit sketch, so it came with everything. You can just program different notes and things. So like one of the elements is this kind of little piezo buzzer, we can use counting it. Spring here, I just had this screwed onto it enough. There's some dirt caught in there, so probably should have got a fresh bottle. But I didn't, that's how the water leaked in. But other than that, like we got we have the pressure washers on both sides, or it's I can pass this around.
It's definitely one of those things that it seems like quite a solvable problem, and it's just a matter of cost and also aesthetics. The folks that I've been working with, they really liked the idea that you'd be doing it in a
It
water
goes
bottle.
along,
Yeah.
And especially for streams around here, nobody bats an eye at a water bottle, but
Yeah.
you see Pelican Cave flowing in the river.
It's a bomb.
Right.
I think that's what everyone's gonna think.
I put some sensors under a fridge in Wisconsin last week, and the next morning when I went back, these Earth Day volunteers were shooing me away from collecting it, saying that they'd already called in the bomb. And so the very
It's
nice.
to see something, say something.
Yeah.
Like everyone is now
Everybody's-
so like that's so ingrained that like to see something that doesn't fit in the environment makes you think, wait, what
Yeah.
is that?
Yeah.
Is this the conductivity thing?
Yeah, we could try that.
Okay.
Yeah.
Because that's the one I don't have. And yes, sorry, I'm totally excited. But yeah, a lot of this stuff is really easily. You can just buy it online. The code's online. I can pull it up again if you go to GitHub and just type in Driftful, and then on the John Blair page,
It's actually, yeah, it's working. Can you hear that? Adafruit, yeah.
okay. And how much was the battery?
The battery is probably $10.
And the charger?
And yeah, the charger's another $5 maybe.
Okay.
So, based on our conversation earlier, where I'm interested in using this to not only teach students how innovation and technology and how sensors work, but also to deploy them and collect information. So for a course like that, would you start with the individual pieces and have students build up all the components, or would you start with having the board assembled? Because then what type of do-it-yourself element is there?
I guess it's a great question, and I guess I've been feeling like it depends on what you want to emphasize. If we've gotten this to the point, which I think we're fairly close, that it is like a commercial water monitor, except that you have to plug the pieces together and run the code. And the focus of the course is not on electronics, then it might just be start with the assembled thing, and then you can think more about the hydrology and what the data means. If you also want to, I guess the next level down would be okay, rather than a curated system for measuring temperature and conductivity, if you want to try different sensors for humidity or light or something, then you might start with the basic board and blink an LED first, and then have a bunch of humidity sensors and say, okay, now go on the web, find the tutorial for that humidity sensor and connect it to this, and then that's your first project. But then you can go all the way down to using a different. So the thing is, there are thousands of tutorials for that particular board, the Arduino Uno board, and when you're first starting out, it's less confusing if you can watch the video of exactly that board and look and see, oh, they're connecting it to that pin, so I'm just going to connect it to that pin. So then I would say, if you want folks to be a little bit more into the electronics, you might start with that board and start with a set of tutorials, and then say, this works just like that. It's just that all of those pins are arranged differently.
Yeah.
So I guess sorry if that's a rambling answer.
No,
but
no, no.
It sort of
And
depends on where you want
It's
to
funny because I
emphasize.
actually think that starting with just a board and doing an LED or a noise and then building complexity into it to measure
Yeah.
environmental phenomena is a really important thing because all these sensors, all they're doing is measuring electricity.
Yep.
And in order for people to understand how data is collected, it's really important to recognize that it's a conversion of electricity to
Yep.
the phenomenon which
Yep.
we know.
Yeah.
And then there's a whole lot of empirical exercises that can be done,
Totally.
to translate that electrical signal into what we're observing. And I think that's what I'm interested in is kind of, how we collect data and
Yeah.
how we use that data, kind of the full story.
Yep.
In a sense.
Beautiful.
Yeah.
But it also makes it more accessible because if you start with that, someone's like, I don't know what that is. Like they don't understand how it's put together.
Yeah.
I don't know. I feel like
Yep.
that distance. Like I actually to feel like it's not intimidating. You kind of want to do it, right?
Bit by bit.
Yeah. So
And-
that you
and-
understand it better.
And the Arduino folks it's just brilliant, the stuff that's online.
Oh, yeah.
It's really thoughtful around how to not be intimidating. Like there's a how-to guide with that.
Oh,
That
here I
is all
can-
drawn in cartoon. And,
Oh yeah, there's instructables.
Yeah.
There's one of the front ones.
Yeah, Instructables, SparkFun has a ton of stuff.
Yeah, so like the ones I'll part of the school do.
Yeah.
Let's put some other stuff. Most of the stuff you just have to kind of peruse either eBay for the Chinese knockoff like you said, or Adafruit or SparkFun.
Yeah.
Which I'll probably from websites up here too. Actually, can I get red?
Oh yeah, yeah.
Sorry, I just like.
And it's great that you're.
Yeah.
Yes.
So,
Yeah.
So are you working on other environmental sensors, or are you working on just perfecting this one?
So the grant that I just wrapped up was focused on remote turbidity monitoring, and the two approaches were build a turbidity sensor, but then the other one was just take a photo of the river, and if you can show that it's highly turbid, apparently the local regulators, or the local authorities, or whatever, they would that would be enough for them to come out and investigate. So this is a cheap security camera that can record images to an SD card. So that was one part of the bomb threat that was under the bridge. That I had that in the rocks looking at the river. And then the other part was that this was in a Gatorade bottle. And this is, I really sort of sweated to make this work over the last month or so. This has an emitter, which is this guy, and a detector.
Backscatter.
Backscatter, exactly. So the principle is that this is in the water, and it's shining light into the water, and you can imagine if the water is perfectly clear, then the light just keeps going. But if there's some particle hanging out, then the light bounces off that particle and goes into the detector. The fancy bit is that you don't want changes in ambient light to affect your measurement, so the sun coming up and going down. So the trick is to pulse the emitter at a high frequency that is higher than you expect any ambient change to be happening. So say the sun comes out behind the clouds, like, pretty gradually, and it goes back, or maybe there's a cloud that passes and so it comes out and sort of, and the frequency associated with that is like, you might say like 1 hertz or 2 hertz or something like that. Um, the frequency that I'm pulsing this at is like 2,000 hertz. So I'm way above most things that would probably generate some interference. And then you filter on the other end so that only signals above a threshold get read in. So this is reading. You can sort of see we've got this plotting live, and if so, lower signal means nothing is scattering really back at it. So if you put your hand in front of it, then it goes up. Yeah. So then the next demo is to stick this in a glass of water and put a drop of milk in it, and then I was gratified to see the signal go up. So anyway, that's what I've been working on is the turbidity. So conductivity, temperature, turbidity, depth is the other thing that I'm going to be working on soon, and but then it's open whatever would be useful. But those seem to be the things that are kind of generally useful in hydrology, that are also simple and cheap to measure, because I mean you can measure nitrate, say, with a very special sensor, I think, but it's expensive and it's very complicated. So
You have a turbidity meter. It's like a little suitcase, and it's got these little bottles of shit, and you gotta sample a bottle
right,
and stick it in the thing,
right,
and then it reads it,
yeah.
and it's $600.
Oh really? Okay, yeah.
And one of our, actually, as our president, dropped one of them in the creek. And,
And that was the end of that. Yeah.
so but that's a great gizmo.
Yeah, and a basic, in terms of education, a basic setup for measuring turbidity that I've seen published papers on is to just shine a light through a vial and measure what goes through on the other side. So it's sort of transmission turbidity measurement. Then, you're worried about ambient light, but if it's just a tabletop experiment, you put it in a box, and then they've gotten it to work very well. So that might be a first thing to do with an Arduino Uno. Make sure that works, and then this is doing slightly fancier things, but maybe that's really only we could also have created an enclosure that wouldn't allow ambient light in, but would also allow water through. But this was trying to make the water bottle work, where you just have a bunch of electronics with a battery that you can just stick in a water bottle. So that's where I tried hard to make it immune to ambient light, but that's overkill for a lot of applications, especially if you're taking water samples back to a lab.
Are you working on, remember you showed on the presentation screen that the measurements of conductivity are in some arbitrary hertz?
Yes.
Are you working on trying to benchmark that out to
Yeah.
micrograms per liter or some other kind of, I
Yeah.
don't know how you're using it.
Well, I was actually talking to one of the guys in the American Fishery Society, and we have access to the YSI sensor, which is the $10,000 one that does that really well. So we were thinking like maybe we could do a bunch of tests to measure, like, okay, this is what the riffle says about it, this is what the YSI says. Try to find an algorithm in there somewhere to try to pair the two.
And I mean that's incredibly straightforward. Like we use connectivity sensors to measure stream flow, the volume over time.
Sorry, what not really live internet stream.
Right.
Now. So I mean, I'll have some funds to help do this stuff. So in the fall, I'll definitely be around.
Yeah, sounds good.
So
Another thing we're doing for our work is we're measuring plant water use, transpiration, and in this part of the world, about 60% of our annual rainfall actually never makes it to streams. It goes back out to the atmosphere through evaporation and transpiration. And so what we do is we stick 3 probes into a tree. The bottom one is upstream because water is flowing from the roots out the leaves. The top one is downstream, and then the center one, we inject the heat pulse into the tree, and the rate at which that heat pulse dissipates is a function of water movement. So it's basically 2 thermocouples and a heat source. And it seems like that would be a really easy thing to program.
Yeah, totally. Oh, easy. Yeah. Oh, fun.
Yeah. And
Cool.
I'd really like to figure out how to do that.
Cool.
You're doing this with trees only?
We're doing this with trees only. We're looking at, there's a large species transition of trees in Appalachia, and the one where it's shifting towards uses more water. So as climate change drives species composition, that composition goes towards more water using plants. What does that mean for water resources availability? Because trees use so much of our water, and how will that affect the region in the next century?
You're going to include industrial hemp in this experiment?
Can we? You certainly could, but we're really focusing on the fact that West Virginia is 90% forested, which is going to be the dominant driver of hydrology. We certainly can be scaled anywhere. We're working with folks to look at how maple syrup production is changing, because that's a function of transpiration as well. So you can do it on hemp production.
I know West Virginia got a license from the Fed because you need to in order to grow it, because otherwise it's a federal felony, which is insane. But, I mean, 0.03% THC, come on. I'm from the 60s and we laugh at crazy shit like that. But my theory is a potential economic and agricultural savior of West Virginia could be industrial hemp planted on 500 bombed flat erstwhile mountains, right? Which the stuff uses virtually this much compared to that much water compared to corn, and virtually non-existent requirement for fertilizer or pesticides. It's a miracle plant. And the fact that America is too stupid to grow it since 1938. Go figure. But we're Americans, so we can do that.
Yeah.
I'm ranting out again.
Okay. Cool.
Where are you from?
I originally Massachusetts and still Massachusetts.
Oh, okay. Did you go to Jeff?
I was thought I might be.
Right. There was departure. You remind me of Jeff Herrick. Spent a lot of time out in Massachusetts with Forest.
Oh, really?
Do you know Jeff
No.
Herrick?
So you live in Boston?
No, he's EPA and
Oh, okay. Oh, cool.
but he gets on a lot of similar.
Oh, really? Okay, so yeah. It'd be really cool to work on some of these things. I'm on the curriculum committee at Emerson College who's trying to make a curriculum around the conductivity approach, but you should jam on that. And then if you can, Public Lab is where I've been working. They have their online infrastructure, like wikis and so on, where you can post stuff. But then GitHub,
I've downloaded stuff to get.
Okay, yeah.
I don't really understand it.
it's not too hard to get going to the point where you can write a wiki and put code there. So that's fun, since if you put that up there, then other people can copy it and improve it. And already with the Riffle, we put it out there, and someone came to visit in Boston, introduced himself, and said he's been designing circuit for 30 years. He's excited about the project. It's weird that I have no idea what I'm doing. I'd love to help, and he's been really helpful. So
great. Yeah, this sap truck sensor that we're talking about,
Yeah.
it's really cool technology. It looks at good properties, which of course is
Cool,
very
yeah.
responsible for energy as well. It's liquid,
Yeah.
and uses convection, convection to, and you just need to create it.
It sounds like it was.
Yes. Yeah. And so in the field, I primarily work with chemical science.
Yeah, sure.
Out there, water, and whatnot.
Yes.
And so we have a couple of these sensors up and running.
Also, if you guys honestly just Google Arduino things, you can make all that tech feeders, there's your solar
And of course,
there's a lot of stuff you can do with
our
this.
current configuration.
And part of this is like, okay, we can get you making this, but then you can also
But it
do
seems
it
like
further
the
and find
scaling
out
issue, you have
yourself.
smaller needle
This
zones
is
to
just
trees,
Yeah.
but you know, you have less power to heat out that one.
And then there's also solar.
Right.
If that's not happening, you could collect them and just do a pulse once in a couple days or so.
Yeah, that would be interesting. All right, I forget what the rest of the day looks like, but I'd love to.
Please, I'm very excited.
Yeah,
Yeah,
awesome.
cool, cool.
You can share on your
That is silicone sealant, and I was going to say one of the tricks is that the water bottles, the material, it's designed to prevent things from sticking to it, so you don't get like weird little things in the water.
Oh.
Yeah, so that whatever that plastic is, I forget, PET or something, is just particularly hard to have anything adhere to. So the trick that a friend of mine came up with was take a rubber stopper from the world of home brewing and jam that into the mouth of the water bottle, and then you
So
can
this goes.
that goes into the instead of the Gatorade tap,
Oh, okay.
jam it in
Well,
there.
sure, but.
The sensors come out of the
So this means you want it to happen. Because I was like, how does
And
the whole time I'm thinking,
Oh,
this
how
is
does
bigger
that
than
come out?
the.
Oh, does that come out of the thing? And right, exactly. Yeah, and then and so then it turns out that you can so that's the trick. So then that goes around the thing, and then that was kind of yeah. So I was trying to right, exactly. Yeah. Well, at the yeah. All the rubber stopper things. Yeah. Yeah, all these things. My friend.
Not just like buying
Sometimes
chicken
I
fingers.
get
I need the top of that.
Right, yeah. There was something festive about disassembling a turbidity sensor. They're saying it's a bomb.
Five, four.
Right, exactly. Yeah, right.
Teachers were too stupid to understand.
Countdowns. I think I
So
will
now he's got a
countdowns.
federal
Yeah, no, we
felony
didn't even
record
have a
on
clock with
something.
numbers on it.
But then he got invited to the White House. To meet the
It
president.
was, he was 4 days away from retirement. He was on tour. And apparently he drew the short story.
Sorry.
Yeah.
No,
Oh, well. They'll have a
must
story
be that
to
chicken
tell.
that's left or this guy.
Okay, starting with the arena. Yeah. Oh yeah. Okay. Cool. Cool. Okay. Yeah. Yeah. Great.
When will you have your gizmo perfected and on the market?
Oh. Well, how perfected do you want it?
Oh, I don't know, how perfected you want it to be?
It's no, that's a great question. I think that within the next couple months, I mean, even now you can buy all the parts. But if you want like it all nicely packaged together, that's probably a couple months from now at least. Yeah.
I think it's great.
Cool. Cool.
I mean,
Thank you for the stories about the turbidity sensor and so on. Yeah.
well, yeah, I mean, these things cost $1,000 or something, and this does not.
Right. Yeah.
And plus, it's small. That'd be fun putting a sign saying, this is not a bomb, it's a scientific experiment, idiot. Please call this number.
Yeah.
All right, just
No, I think that's a good idea. Yeah.
Thank you very much.
Cheers, yeah, thank you.
It's in the open.
I know.
Invitation to vandalism.
Yeah, it's cool. It's just magic.
Hello.
Hello?
Hello. Who are you all? What are you doing here?
I'm a wildlife and fisheries student
Uh-huh.
at the university. Todd Petty actually teaches some of my courses next semester.
Oh, cool.
Every Vesper I teach hydrogeochemistry.
Oh, okay.
Geology before.
Oh, cool, cool.
So I own a lot of data sensors, but I don't build my own yet.
Okay.
So I'm hoping to.
Okay, very cool.
That's why I'm here today.
Okay, great, great.
My name's Emily. I'm a student at Virginia Tech.
It's a panel. Yeah, okay.
I'm Amber, same program as him,
Okay.
wildlife fisheries, and actually just came through the email and it popped up and I was like, this looks interesting, so I signed up.
Oh, good,
That's
okay.
one thing that I'm here.
Someone got my emails.
Yeah.
No, I'm the guy that sends out the emails.
Oh,
Yeah,
okay.
I got the email and I was like, and I was like, all right, so I called off work today, I was like, okay, I know West Virginia State instructions.
Great. Okay, cool. Okay, we're coming from.
Pittsburgh.
Oh.
Yeah, I just drive down 2 or 3 days a week for class.
Okay.
4 more classes and I'm done. That's why I never
Okay.
on campus.
Oh, okay. That's why I never
It's
see you.
because-
Yeah, I see you
I
every
would
once in a while.
love
but-
to be like on campus, but I don't. I live in Pittsburgh, and unfortunately, I can't find a job down here that pays enough that I can also pay for my classes out of pocket. So
Sure.
I'm kind of stuck driving back and forth at this moment.
It seemed like a pleasant drive.
I'm proud of it.
Yeah, okay.
If you do it every day or
Yeah,
every
after 4
day.
years, I'm kind of sick of it. It's a pretty drive at first, and I'm like, I don't know. It's just almost done now.
Congrats.
I'm Paul, and I'm with the Save the Tiger Watershed Association. We do a lot of testing using it commercially, but
Okay.
never build anything like this.
Okay.
Should be interesting.
Okay, good. Yeah, maybe that will intersect with the things you need to do.
Yeah.
Great, thanks.
I'm Jonas Stevek, and I'm a PhD student here in the Forest Resource Science, and I'm working with drinking water quality. So I work with the AFI with Paul Burns and Dora being here. So I've collected some data over the winter and looking at people consumptions on drinking water and water quality from the tap water, and whether they use like bottled water or a filter or nothing at all, just the tap water.
Okay, great. It would be nice to be able to say something about drinking water quality with this stuff
Yep.
at some point. Yeah. Okay, so who here has ever touched an Arduino? Great. Yeah. measure the voltage of the temperature sensor, and when it goes above a certain temperature, because you can convert that voltage to a temperature, see, when that goes above 32 degrees Celsius, then turn a heater on. So this voltage would be connected to a switch that would turn the heater on. So once you have a basic brain here that you can program that has inputs and outputs, then you can do pretty much anything. So if you search online for Arduino and then pretty much anything, there's a tutorial for that thing, like automatic dog food dispenser. or whatever.
We're building one of those right now.
Oh, okay. Arduino pet feeder. Yeah, there you go. Yeah. There you go. Awesome. Wow, it's really big.
Basically just describe building a thermostat right there.
Yeah, exactly. So people, yeah, exactly. So that became really popular. The course lost its funding, and the professor decided to release the schematics for this open source. So if you go to Arduino, this is great. If you go to Arduino and you click on products, maybe Arduino Uno, maybe. Yeah, there you go. So this describes this board, and then as you scroll down, at some point it will be all the details. But then, oh yeah. So if you go to schematics in PDF, so that tells you. So in this picture, the brain is here, and sorry, the brain is here, and then there's another chip on here that's here. The input is this is USB over here, and this all looks really intimidating. But the thing about it is, if you decide that you want to use the same brain on a different board, you really can download this file, copy paste this onto something else, and so it'll show you that somebody very quickly after this thing was published online took the same basic design and said, you know, I don't need to connect it to USB directly. This power circuitry is too high power for me. I just want to run it off a battery. And they used a different version of the same brain. So it's a different package for the brain that is this chip right here. And then this is called the Pro Mini for professionals because they want to use like a smaller version of it or something. So then that is also a board that you can program. And then there became like a whole family of these things. These are similar boards. This is yet another version of the same board. This is, can you see this brain here looks exactly like that chip there. It's the same. So when we were designing the riffle, it is the same brain. See this here. And I really, from this board, I just took some of that schematic. It took a while to figure out how to do it, but once you figure it out, copy paste, and then you've got the brain of that board here. And then we wanted a clock for it because we're going to be logging data in the field for a while. We wanted to keep track of the time. So someone else makes a board that keeps track of the time, and that little chip it's a temperature compensated real-time clock, they call it. It has its own battery. So you see that chip is also on this board, and it has the battery on the back, and I put that on the front instead. And then somebody else had an SD card reader, so we put that there. So this is a version of this that adds an SD card reader, real-time clock, battery management, and then takes all of the inputs and outputs and puts them on the front here, only so that you can have a data logger that is out in a water bottle for a long time. And that was the main jam there. And this battery fits in there, and so that's the battery that we were using. You can use other batteries. And then the conductivity board design, we just designed it so that it could plug in there. And so then that's your sensor that goes in a water bottle and is programmable. And it's programmable in the same way that these are programmable. So all of the tutorials that are out there for programming these are relevant to this. So when you search, instead of pet feeder, if you search for Arduino temperature sensor, somebody has, and you find this temperature sensor on eBay. So a typical thing is like you look up. Oh, great, cool. So you'll look for a cheap sensor on eBay, find it, and then immediately search for Arduino and the name of that sensor and see has anyone written a library for that. Yeah, I think that's even the same. That's the same chip that's inside this, and this is just a waterproof enclosure for that.
So you're building purpose yourself for?
Yeah, so I designed the first ones and then now and sort of redesigned it. The ones that are being used there are artisanal in that I made it by hand. It took a long time.
Yeah.
These designs are up on a website, I think they're up there now, called MacroFab. And you can go to that website and send them one of these designs. Like you could send the design for the Uno, or for this, or for the Pro Mini, and the website automatically identifies all the parts, finds out what the current price is for them, and then adds their labor for producing it, and will make you a quote for assembling it and sending you one assembled, which is what we did with this. So these, in batches of a couple, are about $60 each when you order online.
So you can go to that site and actually order those.
Yep. And, oh yeah. Oh, cool. So somebody else made some other board here. Yeah, exactly. So quantity 1, and then can you change the quantity to like 200? So you see the parts and materials was this, and then yeah. So for 200, so sorry, quantity 1 was how much? So quantity 1 was $60. So $60 times 200 is 1,200. So instead of 12, yeah. So anyway, you get a price break when you order more of them.
This is yours.
No, this is an assembly house and there are a bunch of places like
Oh,
this.
not in the design.
Oh yeah,
Is
this
that
particular
yours?
one is not.
Yeah.
Yeah. So it's an exciting time that you can go from artisanal to mass produced, and you can also, it used to be the case that, and you could always go from artisanal to mass produced, it's just that you have to work with a factory for a long time, and you probably would never order just one. And in fact, even just a couple of years ago, I talked to folks and said, this is terrible, how much will it cost for you folks to make this? And say, well, our minimal order is 500 of them. And I wasn't sure that the design was good enough to like trust that 500, or I didn't have money to do that. But here you can order one of them, and then if it works, then if everybody wants to go in and order a bunch of them, yeah, there we go. So yeah, so basically, so this works just like the Uno. So all the tutorials for the Uno are informative for this, and if you can find a sensor that you're interested in and work it out on an Uno, then it's just a matter of figuring out, well, in the Uno it was this pin, but here it's this other pin, and you're good to go. So
Here, for example, like on there it says on the rifle. When I noticed, like, there's GND and EVO and all those different ones. Same exact thing on the Arduino. Where is it? It's back there.
yeah.
Oh well, so here, if you look, what is it?
Oh, this is maybe a different board, but yeah.
Yeah, this is a little bit different board, but basically there's little things on here that isn't on there. So it's really cool.
Same names of pins.
Yeah.
Yeah.
So the same pins, just different stuff. And
Yeah.
it's really cool how it all works together that way.
Yeah. So yeah, it all maps on.
Is that my temperature sensor, by the way? Sorry.
Oh.
Okay. I don't want to get.
Is that a one-wire temperature
Yeah.
sensor? Oh, cool.
Yeah, I mean, if you just put it in there and it works just fine.
All right, so you should ask questions, but I'll just quickly say that, so you've got the world of sensors, you've got a data logger, there are other data loggers that are out there now, like this one is my artisanal design, but Adafruit, which sells many other cool things, also sells now a small data logger. It doesn't quite fit in a water bottle, but it's still cool. So other things can be done with it. This is a variant of the Uno that has a radio attached to the bottom, and it can talk to another board that also has a radio attached to the bottom. So so that has the radio there, and those can communicate up to like 2 kilometers. So that's really neat, and I've started to play around with those. Then other types of well, and then there's power. So there's circuitry that's out there for solar power and recharging batteries. That right there is a cell phone modem, and you can see on the back the place where you put the SIM card here. So this is a standard SIM card from some service provider, and that will connect to the cell network. So we've got software that allows you to broadcast to the cell network. There's Wi-Fi. So okay, so that's communications, power, solar, battery, plug into the wall. What else?
Where's the live texting? One?
Live texting, yeah.
Yeah, did you show them that one? Where is it?
Or did I just pull it apart? Sorry, is it one of those?
Yeah, probably.
Okay.
Probably, that's okay. But yeah, you plug those right in. And
that the conversion chip is only powered if you're plugged into USB and it gets power from USB, but as soon as you unplug that, it doesn't get power. So when you're on battery, it doesn't drain. So that just tricks like that.
Because I cut out a lot of data logs, but anything that's less than 6 months is important.
Okay, yeah.
Which just gets us into a really serious power. And I set up systems in caves and the water, so solar's not gonna work.
Right. So you need like long-term battery life. That's what I've been shooting for with this, and it turns out that I goofed up when I picked this real-time clock chip, because this is not designed, I now realize, to be on battery power. It's high precision, and it's got its own internal temperature compensation, which is the reason I chose it. But now I've learned how because we're measuring temperature anyway, we can do that compensation and choose a cheaper, lower power chip. So I think that with this thing off and with a few other tweaks, this thing could, like, at least theoretically, it's like a year or more. But in talking to the hydrologists that I was connected to, for them it was, it would only probably stay out in the river for a couple weeks before it would start to foul. I think yeah, for conductivity. But yeah, okay. So then I relaxed a little bit, but it makes sense to try to design this to be as low power as possible. And I think we can get to that.
Yeah, there's some people who've been doing it in cave systems, who've gotten very low power drains on their chips.
Is this Edward Mallon? Yeah. Yeah. So I've exchanged emails with him, and the stuff he's doing is amazing. And his focus seems to be on seeing how far he can get with just off-the-shelf components and wiring them together. So at some point I said, look, we could design a board to simplify all that if that would be useful for him. He said, he'd rather see if he could, because these things are mass manufactured, you can buy these for like $2 each, and then so then it's just a matter. And so for this one, in order to get this to low power, you need to remove this. I think it's this LED here. There's a different LED, but it's one of those things where you buy the thing for $3 online, and then you have to like take pliers to remove the LED that indicates power, because that takes some juice. But that's doable. So yeah, this stuff is amazing.
Yeah, I've met them a few times.
Oh, cool.
They do posters at all our meetings.
Oh, neat. Okay.
Talk about the data.
Oh gosh.
It's an hysterical website. This blog. If you guys are interested in this, this guy it's called Kate Pearl.
Amazing.
Kate Pearl? If you look under that, you'll find Kate Pearl.
Kate Pearl, yeah.
Kate Pearl Project, yeah.
Oh, Kate Pearl and then Mallon or something.
Yeah.
Yeah, there you go. Yeah. Yeah, he's amazing. And that graphic up there is like a PVC container that he's chosen as the enclosure. Yeah.
If you read his blog, you go back to the early days, it's really remarkable.
Yes, and
It's fun.
oh yeah, he's so good. So that's amazing where he's gotten to. So yeah, so that earlier design, I think you can see that Pro Mini like embedded in there and all these wires. Yeah, okay, that's a Pro Mini there. And then like all the wires going to connect to other things, and now he's running off batteries. Oh, that's so cool. That's so cool. Yeah, so we were taking an approach where we were just hoping that you could use a recycled water bottle, but that might end up being a better design for an enclosure. But the cool thing is the code will work the same for the most part, and the sensors that he's playing around with are the same sensors that we can play around with. So very good.
Chunky has a cool blog too.
Yeah. So in terms of building your own, I can see. Oh yeah.
He's writing a book. He's
Yeah.
not promoted, but you can sign up to the newsletter. So we have something differently about every week or 1 year. I love my projects and they're very important.
Yeah, you did a great job.
But it's just cool.
Yeah.
So
Yeah, you did a great job documenting the stuff that you did.
I have years of
Oh yeah. And so Public Lab is the nonprofit that I've been connected to. They have infrastructure there for you to put up documentation if you make variations. Oh yeah, here's our.
Yeah, but I'm not.
As soon as we were very excited about the nutrition facts, because it's going to be like water bottles, so it measures conductivity within this range and temperature and then ingredients and the calories or free double A's, etc. Some of that was aspirational at the time, but that was fun. But yeah, so So if you, this is at the point where you can order one of these assembled. You can, if you want to connect it to the cell network, order other bits and pieces from Adafruit, and you can, basically follow that recipe and build one of these yourself. You also can, say build a conductivity sensor, which is the sort of the design that we have here is that sensor on a breadboard, and play around with that and learn how that circuit works. And there's a list of ingredients for that that's also on Bubble Lab, if that's of interest. So we were talking last session about where do you want to dial into learning a little bit about the electronics so that it's easy to attach different sensors. And in that case, you might start with an Uno and then breadboard other things onto that circuit, and then eventually, create your own circuit board. Or do you want to just start deploying things, and then you might want to dial more into the sort of more pre-assembled stuff that you would put outside and all the stuff there.
I can just play what I have for you guys. So one of the fun things you can do with it, it's just a fun little thing to do. This is just something I do for class, actually. So, see if you can guess it. Taking home. Yes, you can do all this. I've also coded Imperial March too, so that was fun. The Darth Vader theme song. So there's a lot you can do with it, and that's just something fun. But there's also, this is just a great way to start too, just to introduce it. Like if you're gardening and you want to measure soil levels, look it up. Just like mini projects, and then once you understand and learn like what it is and how you can then advance it, then you can try to understand this stuff too. Learning about this really helped me understand that, and I learned about that first, so I was like, whoa, and then I got the lesson and I read the book, and I was like, oh, okay, that's how it works. It's not that scary. It's not that intimidating.
Yeah.
And that's a part of the big factor too. It's like the big bully that really has a soft spot, It's really not that scary. It's like, the brain of this thing is it's smaller than my pinky, So like, it's just cool that it's not scary. If it's something else I'm using here, what's scary about Altoids? Like, actually the ginger one, but other than that, so it's basic, it's cheap. The whole starter kit was $55. If you want it, you can take a picture of it. My starter kit.
So what kind of tools do you need? Do you need like some
No.
things to mount things together?
No,
or
you just need your hands.
Okay.
Yeah, I built this 2 seconds ago.
Okay.
So,
Yeah, no special tools. It helps, I guess, to have a breadboard and
Yeah.
some wires
yeah, I mean it all comes in the kit.
in one of those kits. Yeah.
Oh, okay.
And then if you wanted to put together, how much does that kit cost?
$55 on Amazon.
$55, yeah.
Wow.
But if you wanted to, I've been connected to folks where they wanted to do some event where
Okay, so there are a couple issues. One is you need technical organization.
Yes.
And the other is you don't really have to pretty specific conductance and have a fixed path distance.
Right.
Incorrect for that. So
Yep.
you really make a specific conductivity.
Right.
If you want to go between instruments. And this, but there's no reason why this wouldn't.
It can get there. I mean, the particular problem also with that circuit, I've now realized after reading a little bit more, is that is running at 3 volts and is putting 3 volts into the water. So, right. Yeah, yeah. So most of the instrumentation apparently is down around 0.1 volts. So I have a design now that I'm going to start playing with it. It works differently than that, but it's no more complex than that. So that should be a good next step. The other thing is that in order to avoid polarizing the solution, you need to put an AC signal in there, which this actually is doing. But you need to be careful that you're doing it very symmetrically so that you don't move ions one way or the other over time. And this one is not very symmetric. I finally got access to an oscilloscope, and it's not. so that's the other trick that one has to play with. But those are definitely some solvable problems.
It seems always when you do digital hydrolysis of water, you're looking at solution. If you calibrate it, that ought to fall out of the calibration. So all water solutions. You can measure it.
I don't know enough to. Yeah, that could very well be. My impression was that a friend who's doing a lot of biological chemistry was saying that you're generating a tiny hydrogen and oxygen bubbles.
Axis has changed at the bottom. Best schools are over there. Worst in Florida. Worst schools are over here in all of Florida, right? This is their score in the county. Here are these 5 schools over here. Here's all of the elementary schools in the state. You can see where they score. So less black over there, more black over here, and their scores, passing, reading, and math are up and down. Anyway, so this is another way to dive into data. This is not sensor data, obviously, but it really drives the point home. They're talking about if you eliminate the two privately run charter schools, take away some that are devoted to children with disabilities, and there's 6 schools left, including these 5 schools in Pinellas County, right? This is all in all of Florida. So you get, this is the introduction to this piece. Finally, this one school is the worst performing school in Florida. 160 kids took the state exams, and only 6 of them passed both tests. So this is like, okay, let's talk about what's going on here. And the discussion of this story is amazing. When they talk about how they built this story, the conventional wisdom about how parents were to blame, how poverty was to blame, how all of these other things were to blame. So they asked people to go in and just draw what defines Inwood, and then it was kind of cool. Like 171 people said it went down to here.
Oh, yeah,
some
nice.
went to down here. So that are you from New York?
No, but
Okay.
in DC you would have the same problem
Yeah.
because people are going to dispute
Right.
what is what neighborhood.
Right. So you have to make a decision. I mean, you could do it as an organization. So the problem is, in some cases, it doesn't matter, right? So it's like, oh, it's in your neighborhood, so it doesn't matter, right? But whenever you're counting something like votes, you have to draw a boundary line around it to say, okay, somebody has to go in this one and not in that one.
Right.
And so the city has these things that are they're not great. They're called neighborhood tabulation areas, and where they went in and tried using census tracts, tried to create neighborhoods of roughly the same population in New York, and then they named them. Some classic neighborhoods that we think of got divided into 2 of those. Some have like 3 or 4 neighborhoods clumped into one. And we just went with those,
Okay.
largely because what we're trying to show is a rough division of the city. But a rough division of the city, and because they're roughly the same size in population, that makes this map a little bit more useful, because these are all roughly the same size. But here, for example, this one right here is like Chelsea, Flatiron, Union Square. Like Chelsea is its own neighborhood in
Right.
New York City. Here, but very few people live there because a lot of it is businesses. So that's 4 neighborhoods combined in one. Where over in here, there's areas of like Crown Heights North and Crown Heights South. Those are actually the same neighborhood. We basically said which election districts fall in which of the city's neighborhood tabulation areas, and then aggregated.
You guys have probably entire meetings over this too.
No, I mean meetings of like 2 or 3 of us trying to map this out. Yeah, I mean we spent a whole week building this.
Yeah.
So it would work in real time. That's all the time we have.
And what is that code in that job?
This is in D3. Yeah.
Yeah, see, I like, because those are, when I work, those are watersheds.
Yeah. Neighborhoods.
The
Yes.
ability to scroll in and then
Yeah.
click on one and have it.
Right, for sure.
It's huge.
Yeah.
So how much time went into that?
We probably there are 2 great that she came out.
She was
She's
here.
super cool.
She was very engaged. She just like went right in. That's awesome. I mean, she spoke, but then she also like very engaged with the teams and worked with robots together.
Oh, that's so
and all
cool.
that stuff. So it was very, so thank you.
Yeah, my pleasure. That's excellent.
It's very helpful.
Yay. All right. I'm gonna clear out my.
Yeah, don't want to give it all away at once.
Wow.
So we're going to talk about data and data visualizations today. John pulled up this data set that the Associated Press made available about, what was it, like 3 weeks ago?
I think I
It was
just
like a-
looked at it earlier this week. No,
Yeah.
earlier this week or last week. I can't remember.
It was embargoed for like a week.
Yeah.
So anyway, the Associated Press made this data set available to all members of the Associated Press. So most of your newspapers and radio stations and television stations across the country were all able to see the same data set. They embargoed it because they were working on like a big, USA Today put out this big sort of presentation on all this. But anyway, this is data about lead levels, most recently reported lead levels in water systems across the country. So each one of these rows represents a water system in the country. This happens to be a little section that represents West Virginia. And as a note, the federal action limit for parts per billion for lead in the water is 15 parts per billion, right? So if over the course of an average of a year for quarterly reporting to the EPA, if a water system is above 15 parts per billion, they're in trouble. They have work to do. You'll take a look here. This column right here that's highlighted has the levels as reported to the EPA. You'll notice some numbers here that look pretty funny, like 5,230 and 489, right? Scary initially. However, that's a misplaced decimal point. So basically, whenever I got this data set, I was thinking that elephants were dying of lead poisoning in southern West Virginia, or an elephant could have died from lead poisoning in southern West Virginia. You know, in doing some reporting, we found out that there was a misplaced decimal point. The story has sort of evolved. We're still working on doing some pieces about it. It's sort of moved from the data that was provided to us, which is not necessarily reflective of the current situation, to a story more along the lines of monitoring and reporting that data. So the water system's actually taking the readings, getting that to the state, who then hand it over to the EPA. So I guess we want to start off by saying, you know, just because you have a data set that looks enticing, that looks like there's something there, you have to actually do some real journalism and pick up the phone and make some calls and do some verification and seeing documents. So that's kind of where we wanted to start. And then John's going to take over and talk a little bit more about water and our project.
So one of the things that is really useful to do is to visualize your data, right? So by having quick ways to see and also share what your numbers look like to start that investigation, to sort of look for outliers or whatever, you want to be able to graph it. And there's a couple of ways, there are lots of different ways to do it, and I just want to show you one way that I like to do it. So I'm going to actually, let me get rid of these for a second. I'm going to pull the data. This is a CSV. CSV stands for comma separated values. And I'm just going to open this up in a text editor. Nothing special about this. This is plain ASCII text. And what you have is 5 columns of data separated by commas. So if you take a look at that, you can kind of see it. This is how we got the data off of the riffles. So those bottles, those Gatorade bottles that you saw, this is how the data looks when it comes out, which is actually really cool because you can see it as plain text. It's not encrypted. It's not anything special. What I'm going to do is I'm going to open that in what's basically Excel. I use a program called LibreOffice because it's free. So this is what it would look like in Excel. and it's a little easier to see the columns, right? One thing I always do with my data is whenever I get it, whether it's from a Gatorade bottle or from a government source, I store the original file in a folder called Originals.